To invite another speaker, very famous, Dr. Tarun Gupta. He is a professor in civil engineering department in IIT.
Like as inhaling, and how we can pinpoint what fraction of that is actually coming from combustion sources. So not only vehicles, but also like biomass combustion. It could be cigarette butts, it could be something else in industry, or could be just some of the brick kilns and so on. So from an ambient perspective, how can we really apportion the kind of sources which are out there, and then what are the tools necessary to do that? So that is what I'll walk you through my presentation. Some of the slides are very primitive, but nevertheless, it's required. So particulate matter, just to give a brief, that it can come from variety of sources, and there are a variety of mechanisms by which they are forming. As a thumb rule, we say like big particles are coming from mechanical shear, breaking down of maybe road dust, or like a big kind of machining processes, construction processes. Smaller particles which are more dangerous and reaches deeper part of our lungs are mostly combustion generated, or they are formed as gas to particle conversion due to photochemical or other complex chemical reactions. So that is what we need to remember. This picture itself shows that different kinds of sources are there. Some of them are human-made, some of them are already there in the nature, so forest fire, volcanoes, and just to give you a perspective, the amount of sulfate which comes from volcano or from fire from forest, or maybe some of the hot springs which are naturally there, is actually 70% of the total global sulfate which is out there. So yes, 30% is coming from anthropogenic emissions, but compared to the global natural sources, it's still a small minuscule part. But yet we are kind of playing with the natural, and there are going to be feedbacks, and there are going to be repercussions of that. In terms of classification of pollutants, what is coming out from the sources can be directly affecting us, can be directly transported and reach the receptors, or they may undergo transformation depending on the various kind of physical chemical changes that they undergo while being transported, or the kind of reactivity that these pollutants show when they come in contact with other co-pollutants which are likely to be there in the atmosphere. And that is what causes both climatic effects, aesthetic effects, if we are talking about different kind of man-made structures, or the most important, as Professor Nitin said, that the health impacts. This slide, I just wanted to show that a typical urban scenario, you see three modes as far as particle size is concerned. So what you have on the x-axis is logarithmic particle size. We are presenting geometric mean diameter in micron, and on the y-axis you have normalized volume size distribution of particles. So based on this, depending on what you put on the y-axis, the relative height of these three modes are going to change, but pretty much they will not vanish away. Okay? As far as combustion emissions are concerned, we are typically worried about particles in these two modes, because combustion do not contribute in this mode at all. As far as the health effects are concerned, they can start from the mild effects of sneezing, running nose, itchy eyes, rashes on the skin, to more severe, like maybe like you can say restlessness, headache, nausea, vomiting, or having difficulty in taking breath, or maybe severe ones when you actually need hospital admission if you are a patient suffering from asthma or COPD, chronic obstructive pulmonary diseases, or you have been smoking cigarette for quite some time, left it, still the air pollution gives you that kind of kick which the tobacco used to give you. So sorry for that kind of language, but anyway, so these things have been really like put to the task. There had been like more than 500 studies and even big ones where like almost 30,000 patients have been pre and post evaluated for almost a decade. And some of the famous ones were our Harvard 6 City study, the American Cancer Research Institute study, the nurses study, and so on, where people have really like pinpointed it's not about just your lifestyle, it's not about the kind of medication that you are taking, it's actually depends on which locality you are living in, because that is responsible for what kind of sources you are being impacted upon. Okay, so there have been cities which are known to be vulnerable, like Delhi currently is facing that kind of situation, and it's not just media hoax that people are migrating to give better lifestyle to their children. It's a real truth, because there have been studies which show that a person living in a very polluted city is, even if that person is non-smoker, living in that city per day is like taking 5 to 6 cigarettes or maybe more kind of health effect. So the kind of tools which are used can be automatic, real-time kind of instruments to, but as far as the classical way of looking at it and more reliable is like if you have more control over it, we go for impactors. Impactors have been there for more than 100 years now, and they are beautiful mechanical devices which works on Newton's principles of inertia. Basically, as a snapshot, I am showing the cross-section of a impaction nozzle. What happens is like the aerosol jet or air containing particles which are suspended in it are forced to exhalate through a conical jet, and you put an obstruction right in front of it such that the jet stream have to make a very sharp bend at 90-degree angle. So particles which are small enough, the green ones, they are able to bend along with the bending air streamlines, and they passes the obstruction and does not get collected. Where particles which are big enough, which have high inertia, they go straight and get collected on this kind of substrate, which we call as impaction substrate. And this is how you size segregated wise collect these particles. If you have a cascade of these stages, one after another, you make a cascade impactor. That means size specifically, you are collecting particles of different sizes. And then you can subject to whatever analysis you want to do. If you want to do toxicological analysis, size-based, you can do that. If you want to do chemical analysis, that can also be done. These are some pictures of the impactor, and I'll skip the mathematical details, which are basically very simple coming from Navier-Stokes equation. Some of the simplified version of that, and we are looking at some Reynolds number, Stokes number, which typically determine what size of particles are likely to get collected and what are going to escape the flow regime and get come into the calm section and get collected and impacted on the substrate. This was the device we initially used, an optical particle counter. Is a laser scattering based device where you have a source of laser. As the particle passes through the optical window zone, it scatters the light in all the direction, and this particular device senses the scattering at 90-degree angle, because that is the most sensitive one, rather than back and forward scattering. And it measures, so this device has to be calibrated with particles or dust of known size and shape and known refractive index, and then it can be used for particles of other sizes. So I think there are more than 200 such devices in the country right now, which are typically used for ambient purposes, but very rarely being calibrated. So that is the back point, because people are not aware that it should be calibrated quite often. What we did was we made a testing rig, so very similar to what industrial filter testing rigs are there for testing our impactors, which we designed based on theoretical analysis. So we have an Venturi-based aerosol generator, which actually Dr. Abhijit Kushari had made for jet engines kind of application, but we retrofitted it and changed some of the dimensions internally to be, this could be used in an excellent powder disperser, okay, for low flow rates, and which we actually use in the laboratory to generate stable dust disperser kind of or aerosol generator device. This is our aerosol mixing chamber. Then we have the testing rig with isokinetic probes upstream and downstream of the impactor, and an OPC to measure what is the particle concentration before the impactor and what is coming out after the impactor to assess the efficiency of this. And this kind of analysis was done several times for different flow rates, for different kind of dimensions of the impactor, and different jet to plate distances. I'm showing two setups. So initially we liquid nebulizer, which generally asthmatic patients use for inhalation of drugs, which opens up their lungs and bronchioles. So we got this from the market, put it in sodium chloride solution and generated sodium chloride aerosol out of it, and used a silica dryer, which is basically a denuder system, to take care of extra moisture, and only the dried sodium chloride you can say clusters were remaining. And this is how the size distribution looked like. Pretty stable. So this is 40 minutes worth of reading, readings measured every minute, just to make sure that we are not misclassifying the effect of change in the size distribution of the aerosol generated with the efficiency of the impactor. So this was a must thing. But what we really found was when we use a dry aerosol disperser, what I just described, a retrofitted Venturi kind of dust disperser, we got pretty straight concentration. So we prefer to use this. Later on we changed from talcum powder to dolomite, because that is like a spheroid and they have rhomboid kind of structures and very stable distribution. So we actually took the raw dolomite, sieved it through several sieves, and finally got everything below 40 micron, and that is what we use as a polydispersed aerosol for testing our system. The efficiency curve which we were able to generate actually were pretty sharp. The cut point was around 1 micron, and we could get collection efficiency above 95% with both dry and aerosol and wet aerosols. This is how the initial impactor looked like. This was way in 2009. These are some of the dimensions of the impactor. I'll skip that. Now, what next we did was we used this sampler on the roof of a building at IIT Kanpur. And then this was an year-long study. That is, every other day, like 3 days a week, we sampled for almost a year, 1 year, to cover all the seasons to get not only the mass concentration of submicron particles, but also the chemical information. This graph shows the map of Uttar Pradesh, what are the different industries which are out there. And this gives a snapshot of the mass concentration. So on the y-axis, you have PM1 mass concentration, and on the, these are some of the blocks. So N is the number of readings we had for monsoon, post-monsoon, winter, pre-summer, and summer. When I published these results, like some of my contemporaries were shocked to see PM1 levels of the order of 100 microgram per meter cube, because that was the level or that kind of concentrations were reported by CPCB for PM10, which is an order of magnitude bigger, and they will be contributing more to the mass. PM1 is considered to be giving much lower mass. So people were skeptical about this data, but now I see like this kind of data being produced from Delhi, Kanpur by SAFAR and other such central government kind of sponsored things, and it's pretty routine. I'm like, so this was the real data, which was actually published about 5 years back. We also looked at the chemical species analysis. The reason to look at calcium, copper, chromium, iron, magnesium, lead, and zinc were because these metals are marker for specific kind of sources, and we wanted to tease out. So this is a list of from the sources from which these metals could be originating, and we wanted to, using mathematical equations like which are present for in principal component analysis and positive matrix factorization, we really wanted to apportion what are the sources from which these metals are coming, so that we can really find out what is the percentage contribution of these sources for what is shown in this particular pie chart. So this was the conventional technique, that is, you're using metal tracer analysis to really find out and apportion the sources. Now what we have gone forward now is to look at, can organics serve this purpose or refine our positive matrix factorization or source apportionment techniques? Because if you look at the filter paper, it looks black. This black color is coming from what? Mostly elemental carbon. So some of the source apportionment kind of, or the chemical analysis showed that in Kanpur, so this is organic carbon, this is organic carbon, and then this is elemental carbon, mass-wise lower. But then when we looked at the unapportioned part, maybe a huge part of that is organics, okay, water-soluble organic carbon. So about 60% could be organics. So if we are missing that out, that means we are missing a big thing. In parallel, we were also looking at fog events which are affecting this part of the country. So we were regularly monitoring during the fog time. We were doing diurnal variations, daytime, nighttime, hourly measurements using different kind of instruments. And one of the latest instruments that we have, an aerodynamic mass spectrometer, which can look at single particle, do its chemical analysis, give you the size also. We saw that nighttime enhancement in secondary organic aerosol was happening, and which suggested role of aqueous chemistry. That means in absence of photochemistry, Fenton chemicals like Fenton elements like iron and copper were causing heterogeneous oxidation of various aldehyde and ketones which are coming from different kind of sources, and they were converted into organic acids. Ammonia, because of huge presence from the animal husbandry and other practices, poor sanitation, being present in the atmosphere is stabilizing the organic acids, and because of this, the fog is persistent for long duration because they are acting as excellent nuclei for hygroscopic growth of fog droplets. So this is another part which emphasizes the role of organics. I've just put a cartoon showing from where these elemental carbon and organic carbons are coming. And in continuation of our ambient sampling, we started looking for chemical species. So there we were looking at metals as tracer. Here we looked at polyaromatic hydrocarbons as tracer for different kind of combustion sources from which organic carbon or elemental carbon is coming. So PHs can be present as pyrolytic material or petrogenic. That means it can be present in the fuel itself when you are putting it into the car, or it can be generated during the complex combustion reaction which can happen inside the combustion chamber. So they could be resulting because of lack of oxygen and pyrolytic reactions which are happening in the engine. To pinpoint what is coming before and after, there have been some studies abroad which have been done where they have looked at pHs in the fuel and they have sampled at the emission point. In fact, one of our doctoral student has done that using a kind of device which gives a holistic picture. It does not give individual species, but gives a total particle-bound polyaromatic hydrocarbon and gives you a mass concentration. But in this particular study, we took help from IIT Delhi, Professor Ghazala Habib's lab, and we did HPLC analysis there to find out what are the species present in ambient samples. So I think the number is somewhere. Yeah, we took 24 samples in December 2013 to February 2014. So this was foggy period, and we found out, tried to look at concentration of 16 species in terms of different aromatic rings, number of aromatic rings. This is what the size distribution looks like. So here we have the typical PM1 mass concentration, which is not very different from what I showed earlier. So on an average, about 120 microgram per meter cube of PM1 mass during foggy period. On this secondary y-axis, I have this concentration of polyaromatic hydrocarbons in nanogram, and then and then we have individual components being shown there. What you can see from the slide here, fluoranthene, one of the polyaromatic hydrocarbons, was in excess amount, And I looked through the literature, and it's mostly coming from diesel emissions. And the least one was naphthalene, and there was significant amount of dibenzoanthracene. So after benzoate pyrene, dibenzoanthracene is considered the second most carcinogenic kind of PHS. Of course, nitro PHS are much more carcinogenic, but we could not detect any one of those. So that's a good news. This is what my final slide is. What we did was, earlier I showed that metal signatures can serve as very good proxy for the sources which might be present there and causing the emissions. Here we could, using the bunch of literature which is published earlier and the values that we obtained in this particular study, we were able to relate in terms of ratio of low molecular weight pHs to high molecular weight pHs, or very specifically, so for example, fluorantine versus fluorantine plus pyrene, the ratio of that gives you if it is coming from vehicular emission, is it specifically coming from diesel engine or coal or traffic emission or pyrogenic. So it's not only diesel emission, which was of course the most dominant one even during the fog time, but also wood and coal combustion and biomass burning. A very interesting, using a real-time instrument, we could find that interesting peak in both CO and BC, black carbon, was coming at 4 o'clock in the morning. And since Kanpur is surrounded by villages, and usually to feed the cattle, they start lighting the grass and they burn some crop residue early in the morning. And that signature was a very unusually but very accurately captured by some of these instruments. So I'll stop at this point. The next step is to couple these and refine the PMF models which are based on metal emissions and refine them with organic signatures and come up with a comprehensive source apportionment technique. We have recently commercialized this sampler which was developed at IIT Kanpur, and now it's available in the market. Envirotech Delhi company is selling this. This is the first of its kind in the country. And the most interesting part is it's only 1 lakh rupees, the cost, compared to its foreign contemporaries which are selling it for 16 lakhs minimum. So I'll stop at this point. Thank you very much.
Thank you. Thank you, Professor Tarun. If you have any questions, you can ask Professor Tarun.
Yeah, please.
How harmful is that smoke? While cycling up to the Shivli Road, many times we inhale that smoke. So how harmful is that smoke?
It's very difficult to tell from just physical this thing. I'm like, somebody has to really measure it, what the chemical composition of that smoke is, to really tell what the health effects are. But imagining that plastic is a major part of the waste dumped there, and burning of plastic creates a very toxic kind of organic. Yeah, so what I'm saying is, like, burning polythene or plastic will create very nasty kind of organic pollutants, some of which are carcinogenic. But I don't know, like, we really have, as Indians, very good immunity, I would say, because sure, I think.
This is IIT case list. IIT case
Okay, I think that we can discuss later on.
Okay.
Thank you.
Thank you very much.